Hey, sorry guys. Actually, suddenly the network got disconnected. So I was trying to reconnect back.
Yeah, it's good now.
It's good now. Okay.
Yeah.
Okay. Sorry. Yeah, sometimes it happens in Hyderabad. Power cut makes it, and I should get either data card ready or I should reach out to office and something. Okay. Okay. No issues. Let me share my screen. So we were, yeah. So whether int-writable is interface or class, all those stuff, let's not worry about for now. Akila, let's treat that as a data type. Okay. So we are taking this as a writable, so long writable as your key data type and text as your input value data type. Okay. And here the text is, so the second text is for output key data type and int writable is output value data type. So how I determined that? So based on the input that I'm going to expect, so the default input key value pairs, this is input key value pairs. The default key value pairs will be long writable comma text only for the text files. And output key value pairs. So since I'm going to expect word comma 1, so word is nothing but text and 1 is nothing but either writable or at max, if you foresee very long numbers can also occur for as a count, then you can use as a long writable. But here I use the writable. It just completed our first line of code. Okay. So yeah, Anand, was that clear?
Yeah, Siva.
Okay, thanks. Yeah.
Quickly, the output, so the input, this 1, 21, and 71, this will be all generated by Hadoop, right?
Yes.
By the,
yes.
We don't need to generate that.
You don't need to generate that. You don't need to generate that. You feed your input.txt file as it is.
As it is. Okay.
Okay.
So lastly, what are we then? The only goal is to make sure that it is into that big comma 1, data comma 1.
Yes.
And that is the goal, right?
That is the goal from mapper.
From the mapper.
Yep. So that is what we have seen from the mapper yesterday, right?
Right.
And from reducer, the final total count. So from mapper, this is the output. Comma 1, comma 1, comma 1s.
Oh, yeah. Okay.
So from reducer, we'll write reducer logic again separately in the separate program. So so we need to write 3 programs for any typical Mapreduce job. First, you need to write a mapper and then reducer and then put them and tie them in the driver program.
Yeah, perfect. Got it.
Okay, so now we are looking into the logic of my mapper class. So inside my custom class word count mapper, I don't need to override all other methods. I will override just the map method, which is that public void. It might not return anything. So map method, let's say non-writable. Please keep yourself in mute. Okay. So long writable key and text value and context object, as I was telling you. So this is the class or the object that we use to write our output to the intermediate files. So inside this map method, so I'm not going to override the setup method. I'm not going to override the cleanup method. I'm not going to override the run method. So I'm going to, the default implementations for all other methods are sufficient for me. So most of my 80% of my scenarios, the default mapper class implementations are sufficient. I just need to override the map method. So inside this, so do I need to bother about the line numbers in order to calculate the word counts? Obviously not. I don't care about the line numbers. So I will not take that into picture. So what I want to do is, so you are receiving your value in the form of text format, but inside your map method, does anyone have any question?
This offset value you said, no, that will be taken care by framework, right?
Yep, framework. That will be created by framework, and while processing in the map method, so we will not take that into consideration. We don't need to worry about which line number that word is having. Like,
that's the reason why in mapper phase will not use anything of that specified.
Yep. Let me write the logic, then you will more understand. Okay. So here, one more thing that you need to keep in mind is that, so your inputs coming to the mapper and outputs that you write outside of mapper, they will be of Mapreduce data types. So here, so since your input key value data types and output key value data types you have specified in Mapreduce data types. And same way here, this is the input parameters that you are going to get. This is the input key, and this is the input value. Or you can put as this. Okay. So now you will get your inputs in this Mapreduce writable formats, but while processing inside the Java code, you have to convert that into the native Java data types again. Okay. So string, let me take just the string. Let me convert that into string. So input value is, which is of text type. Let me call toString method on this, and it will get converted into string, one long string. Now I have big data is emerging as a one string inside this string S1. Okay. Now I want to split this. If I split this by space delimiter, so how many values I will get? So big is one word and data is another word. By space, if I delimit, and is another word, and emerging is another word. So you will get 4 elements. So each of them are like string data type only again. So which is nothing but an array of string. I call them as words. Okay. String words equal to, how to parse that? S1 dot split by space. Split S1, this line. So split this line by space delimiter. Then I will get this list of words. Now, so now you've got these words. So next, what I am trying to do is for every word inside this, for every string word from this words array. So what I am trying to do is write that. Now I need to generate output as big comma 1 as one pair and data comma 1 as another pair. Similarly, the remaining stuff. So now for writing this, we have the context object. Inside that we have write method. So write method, you can write word comma 1. But as I was telling you, so input into your MapReduce will be in MapReduce data types, and output from your map method should be of MapReduce data types. Any intermediate logic, they should deal with your Java data types. Okay, so the reason why is it like so, I will explain you slowly. Okay, so here word is which is of string type. I need to convert this into text format. So I can do that by new text of word. And 1 is nothing but an integer. I can do that into int writable by new int writable of 1. And write this. So this will emerge. This will create your output as 1 comma 1.
A quick question, Shiva. And where does it write to? When you say context or write, it writes to a.
It writes to intermediate files, local file system. We have seen this, right? Yesterday. Yeah, Mapper writes your output into a local file system.
Yeah, got it. I was just curious.
Okay. So that local files will get picked up by your sort and shuffle phases, and they will shuffle and they will give the key value pairs as input to. So now your input for reducer, even though you are generating this as output from your mapper, is comma 1 is 1 key. And similarly, after processing all these lines, so if you see big is repeated here once, and data is repeated once, and again big is repeated once, and data is repeated once. So after MapReduce, you will see those many times. Big comma 1 is 1 time, and comma data comma 1 again. And again, this is repeated for line 3 as well. But coming to the reducer's input will be like this: big comma your list of 1 comma 1. So who will do this grouping? That shuffle phase. How it does, we'll see slowly. Data comma 1 comma 1. So here, this is a format. So this is a text format input. Big is a string, right? So its corresponding MapReduce data type is text. And here 1 comma 1 means it's a list. List, or we can specify that with as iterable. So iterable means to denote it is a collection or a list or any type of collection data type. So iterable of int writable. This is the input key value data types for your reducer, and output will be your big comma 2 and data comma 2 will be output. So to produce that in that format, so your output key value pairs will be output key value pair data types will be. So text comma, so int writable. So no collection. This collection got summed up into one integer value. You are giving the final result. So that is the logic that we should do inside the reducer. Now, keeping that same MapReduce program logic, let's write class word count reducer extends reducer and specify the data types, same these data types. Okay, so text comma, your input data type is int writable. Text comma int writable is the input key value. So big comma, once the it's a list only, but that list will specify in the map method. But at class level, will specify this its data type only. Okay, and again its output data type is text comma int writable only. So big comma 1 comma 1 1 you are taking, and big comma 2 the results you are getting. So both are text comma int writables. And now here you are going to override the reduce method. Okay, public void reduce, and it takes the text input key and iterable of int writable as values for that key, and context dot context, same like your map method. Okay, now so inside this reduce method, what needs to be done? So this is a collection. This is a collection of integer numbers. I need to loop through them, right? So first, values dot. For every int writable I, which is of values, so I will declare int sum equal to 0 first. Okay, and I will do the sum equal to sum plus I dot get. So I means int writable. To convert that into int, just I dot get will get the integer value from this. Since this is of integer, I should have the other parameter also as integer, not the int writable. Okay, so this way, if I receive for big comma 1 comma 1 for this list, for this input key value pair, if you take this, sum will be 0 initially, and if you take the first one, then so 0 plus 1, it will come as sum will get 1 then, and for the next value plus 1, so I dot get will return 1 again, and 1 plus 1 turns into 2. So you got the sum. So you need to print that into right output. So again, same stuff. So context dot write of input key. So this time I don't need to convert because input key is already in text format. I didn't use that anywhere here. So it's as it is in text format only. So I use that same text format. Now I should write this sum as count. So new int writable of sum. Right, that's it. So this will finally write big comma 2. So this is the reducer logic that you have to specify.
Ish, I have a question for you. So it could be a very basic. So does all this program has to be copied to all the nodes so that you can run on the data set there?
Exactly. But you don't need to do that.
So it's part of the app master then? I don't know.
It's part of your framework that takes care. And who will copy that? I will show you slowly.
Okay, thanks. Yeah.
Yeah, that's a good question. Like, so it should get copied onto every machine. That is what I was telling you as part of data locality optimization.
Yeah. Yep.
So instead of moving your data, we'll move our code. Instead of moving the data to where your program is running, we'll move our code into data. I mean, into the data nodes where data is present. Because the program might not have more than 10 KB or 20 KB, maximum of like 1 MB, 2 MB. Even if you combine all the jars and all those stuff, it might not be more than 20 MB. Okay. Whereas your data can be 100 MBs, 200 MBs, and GBs. Yes,
Yeah.
these programs need to get copied onto all the data nodes. So who will copy that is, that will be, yes, you're correct that it will be copied by your, first your client will only copy that into HDFS, and who will copy that onto each data node will be done by your app master only. But let me show that through the flow diagram, then you will get it more detailed answers. Okay.
Okay.
Shiva, I have one question.
Yeah, Neetu.
In the reducer method you have shown just now,
Mm-hmm.
when we give the input,
Mm-hmm.
where are we taking care of the thing that key must be the same for values to be summed up? Because
Yes,
whatever
that is for now. It's a gray area for you, and as I was showing you, that will be done by your shuffling phase. So we don't code this part. The default Mapreduce framework will take care of this. We write our programs only for map phase and only for the reduce phase. So this shuffling phase will be done by your Mapreduce framework itself. So how it does, we'll see that sometime in the later sessions.
So basically we are just trying to print the already shuffled.
Yeah, we are trying to process the already shuffled input records by the reducer.
Okay.
Okay. So now I have written my mapper class and I have written my reducer class. I should write my driver class. So I will write my public class. So word count. Okay. So I don't need to name it as driver. It could be anything. Okay. So now here inside this, first thing that I should do is, in order to deal with my HDFS file system, I should have a configuration object, right? As I was showing you in the HDFS Java clients itself, configuration conf equal to new configuration. It reads all the site.xml files and default.xml files. Now you should create the file system object, file system fs equal to file system dot get, we should call the static method by passing the conf object. So now you have the file system, and similarly we should create the job object. Job equal to, I think, new job of, by passing the conf object as well as the job name. Okay, let me show you the exact syntax there. Anyway, once we type all these things in Eclipse, that will help you in finding out all this. Now, inside this job object, so we need to set the mapper class. So set mapper. So what is the mapper class? Word count mapper, that class. And similarly, you need to set the reducer, set mapper. Word count reducer. Reducer that class. And you need to set the input path, output paths also. So how can we do that is file input format. File input format dot set input path. Set input path, you should specify your input arguments or the input directory. So new path of, let's assume, args of 0. So my first argument is the input directory. And the second argument, so we should specify file output format. Where should you write your output path? Set output. Output path. Args of 1. Your second argument to your Mapreduce job, let's assume that as the output path. And also, we have to specify the key value, output key value pairs format, job dot set output key class as, it should be as text dot class and job dot set output value class. Its type is int writable, dot class. And finally, once you set all these things, you need to start your job with one statement, job dot wait for completion. Job dot wait for completion. This is the statement which triggers your job. And all these previous statements are setting your configurations to run your job. So you're telling, so what is your mapper class, what is your reducer class, and what is the output key class, what is the output value class, and where is your input directory, and where is your output directory. Okay, so conf object will keep all configuration files right. Yes. So conf object will read all the core site.xml file, hdfs site.xml file, yarn site.xml file, all those site.xml files and the default.xml files, and it will have all the configurations inside that. Okay. So this is the basic skeletons. Let's get started with the basic templates. Okay. So once you are familiar with this stuff, then we can go a bit deeper if you need. So now I have created the word count and triggered the job. So this will trigger the mapper class. Mappers will get executed, and then reducers will get executed. Mappers will take input from this path, and reducers will write output into this path. So now let's see this in action. Okay, and for writing these programs, not like me, I mean, not like writing in Notepad. We'll write them in IDE, Eclipse. And for in order to write inside the Eclipse, in some of the projects, we'll get the Hadoop Mapreduce Eclipse plugin. Okay. So those Eclipse plugins, sometimes you may get it, sometimes you may not get it in your projects. But one such plugin I have in handy, so I will share that with you. So, and I will tell you how to use that. Okay, let me show you the Eclipse here and help. Window open perspective. So here I don't have the Eclipse plugin, Mapreduce Eclipse plugin enabled here. And if you see in Windows open perspective, other, I don't have anything related to Mapreduce in this. I can't see Mapreduce here. And that's why I don't find any new programs or sorry. All are related to Java tasks only, right? So now let me show you that plugin and use that plugin. Then you will feel very easy to write your Mapreduce programs. Half of the Mapreduce program will come with the templates itself. Let me show you that where the jar is present. Let me take this. Yeah. Hadoop Eclipse plugin. This plugin is prepared against the Hadoop 2.3 version. Yeah, but it will work for even the higher versions as well. Okay. There is a very lengthy procedure preparing this and the behind preparation of this jar. Let's not worry about that. Just understand the, oh, I think I should have here itself. MR unit 2 space client. Let me see if I have in my home folder. No. Okay, so Hadoop Eclipse plugin jar, copying that into here. Okay, so we need to copy this into your Eclipse plugins folder. So by default in your Cloudera Quick Start VMs, you will have your Eclipse installed in your home directory, or yeah, this is the inside plugins folder. Drop this. Let me close this. Okay, so let it get loaded. Now, let's see, open perspective. You can see Mapreduce enabled here. So if you select that MapReduce perspective, you will get so DFS locations also, but in this plugin, this HDFS locations will not be displayed here. This part is not working, but the MapReduce portion is working. So thing is, you can go to new file and see. You can see the new components here: mapper, reducer, and MapReduce driver. 3 new things enabled. So now, if you want to write your mapper class, select this. Even without this, you can write, but let's write with this. Okay, so without this means you have to write all your code same like your plain text file. Okay, so word count mapper, or let me, okay, so, and its a super class is the same mapper, and it expects long writable comma text as input and text comma text as output key and int writable as output value data type. So if I finish this, see, I got the skeleton for my mapper class. Okay, so now what needs to be done is you need to import. In the imports section, I need to import mapper class, I need to import the long writable, I need to import the text, I need to import the int writable classes. So it is throwing error message saying that this is not imported. So what I should do is write an import for int writable. Now, long writable input key, text input value, context, and it can throw IO exception because the file input file may present or may not present. And interrupted exception, it runs through those threads and all, so it may get interrupted anytime. So it can throw these 2 types of exceptions. Now let me put my core logic inside this. What is my core logic? Or let me rewrite that. So my core logic is converting that into I value, convert that into votes, string array votes equal to I value dot to string. It got converted into string, and then I will apply split method on this. So split by space. Now I got the string array. So now I got the string array. So for loop, for every string word from words array, I will print the output. Context dot write what I'm going to write. So new text of word. Okay, and what I'm going to write, new int writable of. That's it. This is one line, this is second line. So I took the input value and broken that by space delimiter. I received a string array, and for every word inside that array, I'm printing word comma 1. And this is for your first record. And second record, again the same map method will get executed. For third record, same map method. For every record, this map method will get called once. Okay, so now I have this mapper class written. That's it. 2 lines of code that I wrote here. Now let me create the reducer class for this. So word count reducer, and my key value pairs are like, so key is text and value is intritable. And always your map output key value data types and reducer input key value data types should be matching. So if you see in the mapper, I have text comma intritable as output key value pairs. And the same should be for reducer input key value pairs. These two should match. Okay. So here, since I didn't import the intritable, so you can see in the import section, the intritable, text, and reducer all are imported. So now, for iterable of, it is not of text, it is of intritable, a value. Okay. So this should be of intritable. Now, so int sum equal to 0, and inside this sum equal to sum plus val dot get, and total sum for the collection get calculated. Now finally I will write context dot write off. So underscore key as it is, comma, so new intritable of. So key is written as it is with total count calculated now. That's it. Even your reducer is completed now. So now let's write the driver for this. So Mapreduce driver. Word count driver. Okay. So I can even select the browser, mapper and reducer here itself. So word count mapper is the one that I wrote. And similarly, word count reducer is the one that I wrote just now. So if you complete this, see it has included the basic import that it want, the job object, file input, file output, path, configuration, all this stuff. Okay. So word count driver, the main method public static void main. So configuration object we have created and then created the job instance, job.get instance of the static method. We are calling the static method on the job class, and by passing the conf object, and second parameter the job name, word count sample, and set jar by class. You should specify, so what is the main class, what is the driver class inside your Mapreduce jar. Okay, so set jar by class. So my driver class is the same class. So word count driver dot class. It will be always the same class name in which you are writing this. Set jar by class word count driver dot class, and set mapper class word count mapper dot class, and set reducer class word count reducer dot class, and set output key class, which is text dot class. Set output value class should be intritable dot class, and you should import that. Okay. Now, so set file input format dot set input paths job comma new path of, let's take this from args of 0. So from your main method, let's pass this args of 1 for this, and job dot wait for completion of true, if that is if that returns no, not 1, then return fine. Okay. So this wait for completion may return either 0 or 1. 0 for successful completion and 1 for failure scenarios. And in if-else conditions, if it is successful, if it wait for completion true, if it returns 0, not 0 means false in if block. So that's why we have this. If not 0 means true, 1, that is correct. Okay, then it returns, otherwise it's fail. Okay, so now we have completed writing the mapper, reducer, and the driver. So we have to build a jar from this. So just right click on this, right click, export Java. You will see Java here, under Java, jar, next, we'll see Mapreduce. Exporting it as a jar we already seen. Okay, so mr.jar, Mapreduce.jar. Okay. So we have saved that jar file in my home directory. So now to run that as a Mapreduce job, first we should have a input file to process, right? Let's take the same input that we have considered here. So input.txt. Okay. So obviously this will not get processed by 3 mappers. It will get processed by only 1 mapper, since this is one single text. Let me put mr input.txt. I'm creating this input text file in LFS first, and then I will upload it into HDFS, and then let's see. Hadoop fs-put mr_input.txt into /user/Cloudera. Into my home directory, I'm uploading this.
Shiva, it is user. You did it as use.
Oh, sorry. Okay, it's my typo. /user/Cloudera. Okay, so now it got copied. We can see there, if you want. Let's confirm the contents there again. So mr input.txt with 137 bytes. Okay. So Hadoop fs-cat. So I can see those contents here now. Okay. So all the 3 lines copied here. Now let's submit the Mapreduce job. You can submit with either yarn jar command or Hadoop jar command. Okay, so yarn jar mr dot jar. So yarn jar followed by jar name followed by the main class. So word count driver is the main class, and you should specify your input path /user /cloudera and /mr underscore input dot txt is the input, and output path is /user /cloudera /mr out. So this directory should not be present already. If this presents, it will throw an exception message saying that this is already present. Yeah, but in this, I don't have the mr out. Let's see. Let's run this job. So file already exists exception output directory. There's no I checked, right? Oh, here it's there. Okay. So either let me remove that directory. So removed that directory. Okay. So let me explain you these messages slowly once this is successful. So the very first step it does is it connects to the resource manager, and resource manager will be running on 8032 IPC port number. Inter-process communication. For inter-process communication, you should reach out to 8032. But for viewing them in the browser, so you should look for on 8088 port number. Let's see that job on the URL also. You can track the job progress there in the browser as well. Okay. So let's see. It's my local machine and it has a lot of services running, right? So that's why it got, it is running a bit slowly. Otherwise, it could have completed. I know.
Siva?
Yeah, Anand.
Is there a standard list of what runs with what port number?
Standard list, I will keep on giving you by service. You have to write down somewhere, or in Cloudera's site, I think you can find, maybe let me put in some table or somewhere, and I will update that in one of our articles. Okay.
Oh, that'll be great. That'll be great. Thank you.
Why is it taking so long time? So it got hanged actually. Let's leave it like this.
Shiva, for me, I tried few. It was running pretty slow. Not these jobs, but the earlier ones, and so probably we should give it some time.
Okay. Yeah. Let's see at least that job until then in the browser. So you can see there is one job running with the job name that we have given in the program. Word count sample is the name that I gave there, right? So this is the application. You can see apps submitted 1, apps pending 0, apps running 1, and containers running. How many containers it's using? 1. Memory used 2 GB. So my total memory is 8 GB. Okay. So active name nodes and how many vCores utilized. So virtual CPU cores. So only one core is being utilized. So active name node is this, active data node is this one. And let's see the application. So you can monitor this applications. Just 3 minutes back, it got submitted. Oh, I think it's completed also. Finished and succeeded. You can see its jobs log messages here. Go and check failed while trying to construct the web. So once this job is completed, the log messages can be viewed through the history tracking URL. So it got moved into history. So here you can check its log messages. See? So as soon as the job is submitted, it routed to 19888 port number. This is what I was showing you yesterday, right? So this is the Mapreduce history server service. Okay, so 8088 is the yarn. This is the yarn. Currently you are in yarn. If you click on the tracking URL for history, then it will be moved on to Mapreduce history server. So let's see this. So let's come back to this counters later in the coming sessions. And for now, let's see the basic messages. So it completed job map 0%, reduce 0%. And after that map 100%, reduce 0%. And map 100% reducer also 100%. So this means job is completed successfully. Now, let's see the output. Hadoop fs minus ls / user / Cloudera 2 / mr out. See, in this output directory, you can see the 2 files here. One is with _success and second one is with part-r-5 zeros. So this _success will be present in every output directory if your Mapreduce job is completed successfully. It is just a flag that denotes your job was successful. And it will be always an empty file with 0 bytes length. So always an empty file with 0 bytes length. You don't need to worry about this file at all. You just need to identify this job is completed successfully. And your actual data files, let's say the number of output files, leaving this success _success aside, the number of part-r files in the output directory will be decided on the number of reducers that were run for your Mapreduce job. So in our case, for this Mapreduce job, there is only one reducer ran. You can see that. Here you can see them in the tracking history. Go to tracking history. You can see how many maps How many map tasks? Only one. How many completed? One. How many reduced tasks? Only one. And how many completed? One. Okay. Even here, how many are failed? How many are killed? How many are successful? Then that statistics you can see. So if there is any map that is failed, you will have that count here. And if you click on that, you will be routed to those failed tasks, and you can see those log messages separately. If you click here, successful, it will go to that map task, and you can see that. And that map tasks, that individual map task logs also, you can see this way. So that means if there is any map task failed, then you can go to that logs. Here. So elapsed time total is 23 seconds. You can see when it was started and when it was finished, how much time it took, all that information. So since it took only one reducer to run this data, run on this data, so you have only one part R file in this. Let's verify the contents of this part R file. See, capital big is repeated once, data capital D, the capital D starting with capital D, data is repeated once, emerging is also only once, Hadoop is also only once, Spark once, big is small case, lowercase big is repeated twice, data is repeated twice, ease is repeated thrice, and D2 are repeated twice. And if you observe these, the data is sorted in the alphabetical order. All the uppercase letters starting with them, they come first, and the lowercase, again, they start with alphabets A, B, D, F, I. So automatically sorted results inside the reducer. Now, I want the same example to be run by you by taking 500 MB file or 1 GB file and let me know how many mappers ran, how many reducers ran, how much time it took. So I want to get that statistics from your end. I need this assignment. You take one such very big file, create 1 GB file or minimum of 500 MB file. So this is the Mapreduce assignment, the first Mapreduce assignment. And this one, I need it by tomorrow itself. Okay, so once you get your
Can you repeat the assignment question once again?
Yep. I'm going to repeat this. So let me write Mapreduce assignment. So run the word count Mapreduce job. Okay. Run the word count Mapreduce job on 1 GB size text file. Okay. And let me know the capture below statistics. Statistics like the number of mappers ran and number of reducers ran And how many part R files .-r-, and these files will have this naming convention. If there is only one part R file, so this will be part-r-5 zeros. If you have second one also, your second part R file will be removing the last one. And if you have third one also,
Shiva, in the code, we need to specify the number of reducers needed, right?
you don't need to specify. Without specifying the reducers, run that. Okay. And observe how many reducers it's running.
Okay.
Okay. So how many part R files generated, and make use of get merge command. Get merge, Hadoop fs-get merge, I explained you. Okay. So if you would have forgotten already this, you can either refer to our article, how to use that, or refer our slides, or refer the video. I want this combined result, or I can tell you what it can does is, if you feed one HDFS directory as input for get merge command, and the local directory as target directory, it merges all the files present in the HDFS directory into one single file and copies that one single file into your local directory, and you can view the results in that. And tell me your observation whether all the records across the part R files, within the part R file, the records are sorted order in alphabetical sorted order. That is guaranteed. Just now we have seen. So all the upper cases will come first and the lower cases come later in the sorted order, right? And within the uppercase, B, D, E, H, S. Yes, they are in sorted order. Within the lowercase, A, B, D, F, I, O, P, T, T, U, and W. Yes, these are also sorted. So within the reducer, your results are sorted. Now, I want your observation whether all the records across the part R files are sorted or not. That means globally sorted or not. So what does that mean by is? So in my part R file, so in my first part R file, I have B. The first word starting with B. In my second part R file, I may have apple as my first word. Then is that globally sorted? Not. So B came first in the first part R file itself, and apple came in the second part R file. That means it's not sorted. Okay. So just answer this question, whether the records will be in globally sorted order or not. And so what else I need from your end is, yep. So for prerequisite, for this is copy the Java code into your Eclipse. Okay. So first assignment is like set up your Eclipse with Mapreduce plugin and write the mapper, reducer, and driver classes, and prepare the jar, export the jar, create input HDFS file and write submit the Mapreduce job. Okay, so this is the first, a typical Mapreduce, and run the same work on Mapreduce job on 1 GB size text file. I don't know how you will download that 1 GB file, but I want you to run it on 1 GB file. Okay, so create 1 GB length text file. So no matter where you get the text for that. Okay, so copy it from anywhere, make it 1 GB size big text file, and then run the same Mapreduce job on this 1 GB file and observe the time it took. Performance time. Measure the performance time. Okay. So for these things, I need the answers. By tomorrow. And remaining assignments, I can wait and I will give them slowly. And I didn't get much time to go through all of your assignments, but couple of them I found interesting, and interesting questions also inside them. And did I give the Linux assignments? I should copy all these assignments somewhere outside. And hopefully I gave the HDFS assignments also. So this is the Mapreduce assignment for today. So you don't need to reinvent the wheel. Just observe what's happening. I'm giving you the code, or I will not paste this program codes as it is. You refer the video and write it. You write it line by line. Don't copy paste the code. At least then you will understand the code. At the time of writing itself, you'll understand the code, the purpose of each of those lines. Okay. So run that code and build a jar, execute on the cluster, and then observe, provide me your observations by tomorrow. And let's remaining stuff tomorrow. Yep. Yes, Anand.
If you were using the mapper, like it only used one mapper and one reducer.
Yes.
Is that because of the size of the file?
Because of the size of the file. As I was telling you, right? If I upload a file, how will it get splitted into blocks, right? And each block will get processed by one separate mapper, right? Number of splits or number of blocks equal to number of mappers. Okay. So yeah, so try to create 1 GB size file and upload it into HDFS, and then show me the Mapreduce job statistics that I requested. So till now you might have seen only simple text files, 10 lines, 20 lines of code files uploading into HDFS, and every time you always see one block only there. So if you upload now 1 GB file, it should create some 8 or 16 blocks. If it is 64 MB size, of course it's not. Let's not discuss that, and let's not confuse others. It's by keeping 128 MB as block size, you will have 8 blocks in your HDFS, and then run your Mapreduce job. See how it goes. Okay. So how many blocks it's created? Only one or which one? That 1 GB file? Oh, I think this question was posted with 15 minutes back. By now, I think you got the answer as well. Okay. Is everyone clear in the coding part of it? It's not rocket science. It's simple only. In Mapper, you have written 2 lines of code. In Reducer, you have written 2 lines of code. And in your driver, it's a regular skeleton. Once you write one driver, that's it. If you want to write 100 Mapreduce jobs also, your driver skeleton will be like this only. So once you learn it once, you can write hundreds of Mapreduce. And even in the Reducer side, only these are the 2 lines of code that you have written. And this is all remains similar for all other Mapreduce jobs. And even here, these are the 2 lines of Mapreduce code that we wrote. Remaining stuff, your Eclipse plugin itself has given you the template. So
quick one, Siva here. The override part, what is that for?
Override means it's already there. I have shown you in the inheritance class, right? So if this method is present in the parent class, parent mapper class, so here mapper is a parent class, right? That we are extending and writing a subclass word count mapper. And I am overriding the map method logic that is present in the mapper class.
And what is the reason to do so? Because
in my parent mapper class, it does nothing. It just takes the input and writes that input as it is. But I don't want that in my subclass, right?
Sure, that's identity mapper.
What is it?
Identity mapper.
Metadata?
Identity mapper.
Identity mapper, yes. So regarding this 1 GB text file, we only have to create and use it, or there is some sample file you will give. Even if I give, it will take a lot of time for you to download this Faru. My suggestion is to create it. Okay, create. I mean, any manner. I don't have any issues. Did you get it, Anand? This
I'm digesting it. I'll probably go over it once.
This is inheritance concept. This is a parent class. This is a subclass. And this method is present in the parent class. And we are in the parent class map method. It will not do any job other than copying the input and pasting as it is, writing it as it is in the output. But you don't want that. You need to parse your input record and break that into words and then generate the counts for them. So you don't know your parent map logic. So that's why you have used override and you have provided. So this is like method overriding, right? In polymorphism, I have shown you, but I was, quickly covering those topics that day. Yes, I know. Yep.
Okay. Shiva, is Mapper is abstract class or what?
Mapper is a implemented class only. It's not an abstract class. If it is an abstract class, then I should have provided the implementations for all other methods also, right?
Maybe I think
yeah, but this Mapper is a regular class only, not an abstract class.
Okay.
Any questions? Hemant, I need your opinion. Hemant?
Yeah, Shiva, sorry.
Yeah, I mean, are you clear?
Yeah, I have to put in more practice, that's it.
Okay.
I can understand the concept, but
Okay.
just
Yeah,
to
so once you learn this program today, so more or less your any other MapReduce program, the 60% of your program code is done. The remaining 40% is the core logic that you will write inside the map method and inside the reduce method.
okay.
Siva,
Yeah.
Siva, there is no automatic tools to do this.
Automatic tools in the sense, yes, you will see them in like Hive, Pig, those will do these things. We'll see those tools next. So they don't write this code, they will have their own syntax. If you use that syntax, that logic will get converted into MapReduce jobs and simplifies your complexity of writing MapReduce jobs.
Got it. And even for the bigger files, is it still same number of code lines, right?
Even for the bigger files, it doesn't depend on the number of records, input records. It's the same lines of code. That's it.
It's only when you have to alter the logic or something.
Yes.
But typically, you just get the file, you input that file, get the map out of it, and that's it, right?
Yep. That's it. Okay. Any more questions? Okay. Okay. Go to sleep, Lakshman. Yeah. Bye-bye. Let's meet tomorrow, same time, and let's discuss the yarn job anatomy. So what are the flows that are involved in the submission of this job? How does this job get submitted? And how does the task will get triggered? All that stuff. And failure scenarios. Okay. So those concepts, let's see tomorrow. Try uploading this video as a, yeah, sure, Srinivas. Sorry. Thank you. Bye-bye.